Right, we're looking at the Lesson 26 practice problems from Illustrative Mathematics Algebra 1. This is on page 373 to 376 of your student workbook. We're going to go through and just do a couple hints on these. As always, you should be practicing homework independently at home to make sure you understood the lesson and come to class the next day to give questions to your teacher. The organizers of a conference need to prepare at least 200 notebooks for an event. They have a budget of 160 notepads. The store sells notepads in packages of 24 and packages of 6. So I just want you to notice, again, really want you to highlight important information, that the 200 notepad that shows up here in this inequality uh, goes with the packages of 24 and packages of 6. So these all get put together into one inequality. And then in the other one, it mentions a budget of 160, which we see show up here. So it says explain what the second one means. So obviously this one's talking about the budget. And so what do you think the 16 mean? And what do you think the 540 means? Answer that in A. Next, it gives an incomplete graph of the inequalities in the system showing only the boundary lines. Notice they are both solid lines because each inequality has the equal to bar, so that's already correct, and you're just supposed to determine which line is which and which shading should be greater and which shading should be less to create the small wedge, the region that is overlapping. I highly recommend you use two different colors to highlight so you can see where those two touch. One method of graphing we've learned in class is to graph by intercepts. So if you go ahead and get the intercepts over here off to the side on your work for the first inequality. So this one right here is getting the x-intercept when y is 0, and then getting the y-intercept when x is 0. And if you finish off that work and divide, you'll be able to see the intercepts and then hopefully go choose the correct line. Then for the second inequality, you'll notice right here I started the work of doing the same thing. Go get the x-intercept of this bottom one, and then go get the y-intercept of this bottom one, and then hopefully you can identify which line goes with that. Next, to complete those graphs, it just means you are going to add the shading that goes with the inequalities once you've identified which line is which, and then finding a possible combination of large and small packages would be finding any XY pair that is in the double shaded region or the overlap of the shaded regions. Okay. Next one, a stylist charges 15 per haircut, 30 for coloring, and takes an average of minutes. Total coloring is 2 hours. The stylist works up to 8 hours and she needs a minimum of 150. So these word problems like to mix up all the information, but we want to keep the important information together in our minds, like money goes with money goes with money. That's going to represent the first inequality that you can write. And then the second one has to do with time. A haircut is 30 minutes, coloring is 2 hours, but we can't go any more than 8 hours, up to 8 hours. But be careful with this because 30 minutes and 2 hours and 8 hours, we want that all to be consistent in hours. So you're going to have to convert the 30 minutes into hours. What do you think that's going to be? You got it. It's a half hour. Make sure you use a 0.5 for that so that everything matches. 0.5, 2, and 8. When it says up to 8 hours, are you going to use a greater than or a less than? Will there be an equal to? When it says a minimum of 150 a day, is that greater than or less than or equal to? What do you think? In graphing the inequalities, the two things we're talking about here are haircuts and coloring jobs. So it can get confusing, like, am I supposed to put money on one of these axes. Am I supposed to put time on one of these axes? No, it's actually haircuts and coloring where the line is going to represent the budget line and the line is going to represent the timeline. So those two lines that you create on here are going to have to do with the budget and time. Identify a point that represents a combination of haircuts and hair coloring that meets the stylist requirement. So after graphing the lines and the shading, choose a point in the solution region. And remember that the solution region is the double shaded area, the overlap. So any number of haircuts and coloring jobs that fit within that double shaded region. Identify a point that is a solution to the system, but it's not possible or not likely. Explain why the solution is impossible or unlikely. So think about that one a little bit and see what you come up with. Next one gives you a system of inequalities and asks you just to choose the graph. Notice the two lines on both are the exact same lines. You're really just choosing the shading. In regards to this second one, I encourage you to do a little work. Do you want to graph that by intercepts? That means to do the work of the x-intercept, the y-intercept, to see where that graph should be touching. Or would you rather put it into y equals mx plus b format by adding the x's and dividing by 3? So you've got to figure out which one of these two methods is more your style in order to be able to choose the correct graph. If you use the intercepts method, you then have to choose a test point to figure out the shading. Remember, the easiest test point to choose to test might be 0, 0. In this other one, we're just going to use the less than or equal sign to choose our shading, but I also encourage doing a test point to make sure you did it right. So is your answer A, B, C, or D based on that? Go figure it out. On this next one, you're matching a one-to-one, like A goes to which one of these. There are 5 graphs and 5 numbers. I'll do one with you, and then you can go find the other. So I think working off of the equation is where I would go with this. But again, you could work off of the graphs and go towards the equation. It's up to you. So if I were to do this one by intercepts, for the x-intercept, the y is 0. We would get the x-intercept as 10, 0. For the y-intercept, the x is 0. And I notice that I am going to get a negative y-intercept. So let's go look and see which graph touches at 10, 0 and negative 4, 0. Now, since there's not more than one with those intercepts, we can assume the shading is good, but I'm going to show you the 0, 0 test point and how we would do that just to be safe. 0 minus 0, is that greater than or equal to 20? No. So 0, 0 is not a solution to the system, and we notice that the other side is shaded. So C is the valid solution to number 1. You're going to go do the same thing to 2, 3, 4, and 5 and see which graph it matches, okay?